All right, so welcome back to OneClass. Again, my name is Joey. I'm going to be your OneClass teacher for this session here. So again, here at OneClass, what we're doing is we're providing kind of online solutions and resources and live streams for kind of students at home, kind of taking secondary level math or chemistry courses in both the secondary level as well as the college and the university level as well. So what we're doing here is, despite the school closures because of COVID-19, what we're doing here is that we are providing kind of resources so you can still kind of learn at home and kind of access these resources at any time you want. These resources are always uploaded onto YouTube, so you can subscribe there at the OneClass channel, so you can kind of follow along and keep posted, and basically kind of get notifications and be kind of notified whenever we have a new video that's being uploaded. So again, my name is Joey. I'm currently a secondary school teacher within Ontario. My specialized subjects, or my teachable subjects, are math and chemistry as well. So without further ado, let's get started again. Again, I have about 10 to 11 problems in about kind of grade 9 to grade 9 math, grade 8 to grade 9 math here. So it's mostly just pre-algebra, algebra 1, and maybe some geometry questions as well. So let's get started for today. All right, so we have here, what's the first question is asking us, what is half of 112 cups? So again, simple measurement question here. So it's asking us half of 112 cups. So what is half of 112 cups? So when we talk when we have cups here, again, cups here is a unit of volume, right? So unit of volume, and it's in, again, the empirical system here. And it's measuring volume. So these are it's just measuring kind of, like, you can think of it as water or juice or whatever, like this, something like that. So it's asking us what's half of 112 cups. So basically, all we're doing is we're taking half. So again, 1/2, and then we're multiplying it by 112 cups to figure out how many cups we have so far. So you can think of it as half times 112, or you can think of it as 112 divided by 2. It's honestly up to you as how you think of this problem. Again, half of 112 here, what I can do is I can simply just divide 112 divided by 2, and this would equal 56. So this here equals 56 cups here, and you could plug this in your calculator, or you could do the old-fashioned kind of long division here. So if you have 112 and 2 here, so if you don't have a calculator, we could solve this using like pencil and paper. So again, 2 times what number goes into 11? 2 times 5 goes into closest to 11 here. 11 minus 10 here is 1. You bring down the 2 here. 2 times what equals 12? It would equal 6, right? 2 times 12 equals 6, and you would get 0. So you get 56 cups is half of 112 cups here. So the solution here is correct. It's 56 times. They want it in gallons. Oh, they might have wanted it in gallons. So let's switch this into gallons first. So we have 56 cups first, and then it didn't say here to convert to gallons, but maybe I'll convert to gallons for you as well. So let me just write out the conversion rates for you. So I have 1 gallon equals 4 quarts. And then 1 quart equals 2 pints. And then 1 pint equals 2 cups. So they're converting from basically cups all the way to gallons here. So in order for me to do that, I'm going to have to, I start with 56 cups, like we kind of solved in our equation here. We have 56 cups here. We're going to multiply that by, I want to convert into pints first, and then to quarts, and then to gallons, right? So I would have to do 1 pint here equals 2 cups. So I have 2 cups in a pint. 2 cups in a pint. And then I have 1 quart, or 2 pints is 1 quart. And finally, 1 gallon here is 4 quarts, right? So as you can see, my units are canceling out. Cups cancel out here. Pints cancel out. Quarts cancel out. I'm left here with gallons, and that's what I want, right? So I have 56 times half times a quarter, or you can say 56 divided by 2 divided by 2 divided by 4. So 56 divided by 2, which is 28, divide that by 2 would be 14, divided by 4 would be 3.5 gallons here. So this here would equal 3.5 gallons here, and this solution here is the correct answer, and as you can see, it's 3.5 gallons as well. So the solution here is correct. Good explanation here. So I didn't know whether or not they want to be in cups or if they would need to convert to gallons. The question just simply asked what is half of 112 cups, but again, we can convert into gallons or quarts or pints depending on depending on which conversion factor we are using here. So solution here is correct. Okay, number 1, yeah. Number 2 is asking what is the smallest angle of rotational symmetry for a square? So smallest angle of rotational symmetry for a square. And then it's asking, and then we have kind of, what we're doing here is they have like a diagram here. So I'm going to redraw this diagram. And this diagram is actually really, really good because it shows us, again, the 4 sides of a square. So A, B, C, and D. And then they want to change this into, they want to rotate this square into D, A, B, C. So they want to rotate this basically 1 step clockwise. So you can think of it as rotating kind of clockwise, and it's going to switch places to become kind of this guy here. So D becomes this top right corner, A becomes this top right hand corner, B is bottom left, and C here would be bottom left here. So what is the smallest angle of rotational symmetry for a square? In this case, what we need to do is we have to rotate it by 90 degrees, right? So this guy has to go, A has to go to, this one here, and D has to move up, right? So again, if I'm moving up by 1, I'm shifting it kind of 90 degrees towards base 90 degrees clockwise here. So this would be, I'm rotating it by 90 degrees clockwise here. So if you think about it in terms of an XY plane here, I have to rotate it again 90 degrees. If I have a square here, I'm gonna have to rotate it again 1 step this way in order for us to get this kind of square here. So the smallest angle is indeed 90 degrees here. So this solution here is correct. Correct. Good explanation. Let's look at number 3. It's asking us what is the square root of 144. Asking us what is the square root of 144. So take a moment to think about this question. Again, we've done a lot of square roots already in today's video. So maybe think about this this question as well. So 144, and we're using this topic of prime factorization, right? Prime factorization would help us solve for these roots here. So let me write down prime factorization. And basically, we're just taking out prime numbers from this big number for us to simplify our radical, right? So 144, again, 144 here, I can convert this. I can take out a 2, right? I know it's an even number, which means 2 is divisible by 144. Or 144, sorry, is divisible by 2. If I divide 144 by 2, I'm going to get a number of, I believe it's 70 or 72 here, right? Is it 72? I think so. 140, yeah, 72. So 144 divided by 2 here is 72. And then I can take this number, I can take 72, I can divide that 2 further on, right? So I can take another 2 out from 72, and then I'm doing 72 now divided by 2 is 36, right? 36 here. And we know that now square root of 2 times square root of 2 here, we know root 2 times root 2 will give us root 4, which is simply just 2, right? So the square roots are going to cancel out. So I have 2 here, and then finally times root 36. And I know the square root of 36 is 6, right? So 6 squared is 36, so therefore square root of 36 has to equal 6 here. 2 times 6 simply equals 12. So the square root of 144 is a perfect square, and it will equal 12 here. And the solution here is correct. This here, yeah, the solution here is correct here. So solution is correct. Good explanation. Number 3, and then finally number 4, not finally, sorry, just moving on, number 4. It says, write the phrase that represents the algebraic expression 5x minus 9 here. So I want a phrase, that represents, basically the algebraic expression is 5x minus 9, right? So we have basically 3 parts to this. We have 5 here. So if I'm going to do this in red, so 5 here is, again, I'm multiplying something by 5, right? So this is, I'm multiplying by 5 here. I have an unknown here, so I can just write unknown, because I know x here is my unknown. And finally, I have negative 9 here. 5x minus 9, I am subtracting, or taking away, subtracting by 9, right? By 9 here. So in order for me to write a phrase that represents this, I'm simply going to be, it's going to be simply an unknown first, because I care about my unknown first. So I'm going to write a number, or I can say basically 9 take away. So I'm going to write 9 take away 5 times a number here, right? Because I can say here, this unknown is simply just a number. So if I want to write down my my phrase here, a number is simply unknown. So and then multiplying by 5, right? So I can say 5 times a number. 5 times a number is 5x, and then I'm taking away 9, right? So it's going to be 9 take away 5 times a number, right? So 9 take away 5 times a number here would be my correct answer for a phrase that would represent 5x minus 9. And again, they have this here. So they're saying that it's 9 is subtracted from a number multiplied by 5, which is the exact same thing as 9 take away 5 times a number here. So this solution here is correct. Or it says it is a difference of 5 times the number and 9. And this solution is correct, right? Again, with words, there are a lot of phrases that you can use to kind of like represent these word equations here. Actually, like, it is a difference here. So I'm actually going to erase mine here. And actually, like it's saying here, it is a difference of 5 times a number and 9 here. So I kind of like that as well. So difference of 5 times a number and 9. I kind of like this one a lot better as well. So this solution here is correct. Good solution and analysis here. Let's look at number 5. It's asking, what is the greatest common factor of 45 and 75? So let's see. So I want to find the greatest common factor of these two numbers. I have 45 and I have 75 here. So basically what I would do is I would figure out what are the factors of 45, what are the factors of 75. So let's write down the factors of 45 here. So 45 would be, I would have basically 1 would be a factor of 45, 2 is not, 3 is not, 4 is not, but 5 is, right? 5 is another factor of 45. 5 is a factor of 45 here. And 6 here is not, 7 is not, 8 is not, but 9 is, right? 9 times 5 here is 45 here, right? I have 9 as well. And I believe that's about it. I don't think, actually, no, I think 15 also goes into 45. 15 times 3 here is, 15 times 3 would be 45. So it'd be 15 as well here. Would be another factor, because 15 times 3 here is 45. Let me just check. 15 times 3 is 45. I think 3 is also a factor. So I think I'm missing a 3 here. So 3 is also a factor. 5 is a factor. 9 is a factor. And 15 is a factor here. And then I have a factor of 75, right? 75 would have, again, the 1. I would have 3 as well. I don't think I have 3 in 75. Oh, no, I do. I do have 3. Yes, I do. I have 3. I have 5 as well. I don't think I have 9. Correct me if I'm wrong. Yeah, I don't have 9 as a factor. However, I do have 15 as a factor as well, right? 15 times 5 would be 75. And then I would have 25 as a factor as well, right? 25 times 3 would have been would be 75 here. So I'm looking at the greatest common factor. I'm just looking at these two terms here. What is my greatest common factor? In this case, it's 15, right? 15 is my largest number here, and it's also common here, right? So 15 here would be my answer, and they have it correct as well. It's simply just a product of 3 and 5 here, right? Products of 3 and 5 and 3 and 5 here. So these are my greatest common factors. 15 here is my greatest common factor between 45 and 75. Solution is correct. Good explanation. That's number 5. Let's look at number 6. We are pedaling away with these questions here, which is great. What is half of 2 to the 6th power? Half of 2 to the 6th power here. So it says I want to say a half of 2 to the 6th power, right? So 2 to the 6th power is simply just 2 to the 6th, right? 2 to the 6th. And I'm taking half of this number. So I'm going to basically do this exponent first, and I'm taking half of this number, multiplying by half, right? So in order for me to do this, I can simply just rewrite this as, again, half times basically 2 times 2 times 2 times 2 times 2 times 2, right? It's just 2 to the 6th power. So I'm writing 2 times 2, like basically 6 times. So 2 times 2 times 2 times 2 times 2 times 2. And then I just have to simplify, right? So again, half times 2 here is 1. So these two can cancel to 1. And then I have 2 times 2 times 2 times 2 times 2. And then now it's simply just 2 to the 5th power here, right? So again, 2 times 2 is 4. So 2 times 2 is 4. 4 times 2 is 8. 4 times 2 would be 16. And finally, 16 times 2 would be 32 here. So 32 would be my correct answer for this solution here. And as you can see, simplified result is 32. So exactly the same solution here. Great solution, great explanation here. Number 7. I might have to add more questions to the stream as well, just because we are kind of speeding through this. So it says, how many cups are equivalent to 1 pint? To 1 pint. So again, what we have here, again, we have to write out our kind of conversions. Again, we have it's in the empirical system. We're measuring volume. So it's simply just, again, my conversion rates are, I get 1 gallon is 4 quarts. One quart is 2 pints, and 1 pint is 2 cups, right? And as you can see here, 1 pint equals 2 cups is my answer, right? How many cups are equivalent to 1 pint? 2 cups are equivalent to a pint here. So as you can see here, 1 cup is equivalent to half a pint, or you can say 1 pint here equals 2 cups. So this solution is correct, but I don't think they actually explicitly say. They wrote this down here. But a cup is defined as half a pint, which means there are 2 pints in the cup here. So solution is correct. Should specifically say that 1 pint equals 2 cups in their solution. So the solution here is correct. All right, that's number 7. Look at number 8. Number 8 says, how do you convert 2/3 to a percentage? So I want 2/3 into a percentage. So basically, I would take 2/3 and I'm going to basically multiply it by 100% for me to figure out the percentage, right? So again, percentage just means 100%. So I'm taking 2/3, I'm going to multiply that by 100% in order to figure out how much percent that is, right? So in this case, what you would do is you would, again, you would take 100% here is basically 100 over 1, right? So it's 2/3 times 100 over 1. So 2 times 100 here is 200 divided by 3, right? And I would have to figure out what this is in percentage, right? So I would have to basically convert this into a mixed fraction. So in order for us to do that, again, I'm simply just doing 3 divided by 200 here. And I'm going to do long division, right? So 3 times what number would give me 20? 3 times 6 is closest to 20, would give me 18. 20 minus 18 here is 2. Bring down another 0. Again, 3 times what number is 20? Again, it's going to be 6. So again, 18. So 20 minus 18 here is 2. And as you can see, it keeps repeating, right? Because I all have zeros here. So my 66 is going to go here. And as you can, I bring down the 0, it's going to be a 6 again. And then this process is going to repeat again, right? So again, it's going to be 66.66, and basically it's going to repeat. So basically what percentage do I have here? I'm going to get basically this percentage here. It's going to be 66.6, basically bar percent here. And the bar just means that the 6s are repeating here. So this solution is 66.6% here. And as you can see here, it says 2/3 times 100% equals approximately 66.67, exactly the same answer as I got here. So solution is correct. Good explanation as well. That's number 8. Number 9 is another conversion kind of question here, asking how do you convert 1/12 into decimal and a percent. So 1/12 into a decimal and percent. So I'm going to do decimal first. So all I'm going to do with decimals is I'm going to, again, take 1 over 12. I'm going to do 12 divided by 1.00 to get my decimal, right? So I'm going to draw this out. 12 will be my my divisor here, and my dividend is 1.0000. And basically, these are just zeros to carry my stuff over, right? 12 times what number? Oh, sorry, let me put my dot here. 12 times what number would give me 100. 12 times, I believe, would be, let me do this in my head. This would be 8, I think. 12 times 8 gives me 96. 100 minus 96 here is 4. Bring down the 0 here. 12 times what number would be closest to 40? 12 times 3 would be closest to 40 here, which would give me 36. 40 minus 36 here is 4. Bring down the 0. It's going to be a 3 again, and it's going to repeat as well. So this is 8.0. It's going to be 0.083. Repeating would be my decimal, right? So 1/12 would equal 0.083. And this would be my decimal here. And simply, if I want to convert this into decimals, again, I can simply, if I want a percentage, I would simply just multiply by 100%, right? So 1/12 times 100% would give me my percent here. So in this case, it would be, I can reduce this to 6 here. This would be 50. I can reduce this further to 3. This would be 25. So it'd be 25 over 3. And then I could convert this into a mixed fraction by simply just dividing 3 by 25 here. This would be simply 3 times 8 here is 24. 25 minus 4 here is 1. I can bring down a 0 here and we get 3 here. So this would be 8.3 bar percent, which is exactly the same thing as this guy here, right? So 8.3% would be my answer for the percentage. So again, as you can see, percentage is 8.33. That's good. And finally, they did long division like so, and they got 0.083 as well. So this solution here is correct. And it has a good explanation as well. Good explanation. And then finally, we can look at number 10 here. Number 10 says, solve for the indicated variable, show all the steps. So I have kind of, it's a 4-part question here. So let me do A first. So A is stating this is negative 4y equals negative 52. I'm going to solve for basically the variable. I'm solving for y, right? So if I want to solve for y here, what I'm going to do is I have, again, y is already on one side here. I want to get rid of this negative 4, right? So I'm going to divide both sides by negative 4 to get rid of the negative 4 on my left side. So I have y here equals negative 52 divided by negative 4. Y would equal 16 here. So the negatives cancel out. I would basically get 52 over 4, which equals 16, I believe. Let me just check that on my calculator. 16 times 4. Oh, no, it's not 16. Sorry. I think it's 14. No, it wouldn't be 14. It's 52 divided by 4, which is 13. Sorry, 13. So y would equal 13 for A here. B is asking x minus 2/3 equals 3/4. So again, I want to get rid of the negative 2 over 3 on the left side. So I'm going to add both sides by 2/3. So I would get 3/4 plus 2/3 here. And then again, I can use common denominator to add these guys up, right? So the common denominator between 4 and 3 would be 12. So it would be, again, 4 times 3 is 12, which means 3 times 3 here is 9. Plus, again, this would be a denominator of 12. 3 times 4 would be 12 here. So 2 times 4 is 6. So finally, I would have a answer of x would equal 6. 9 plus 6 here is 15 over 12. So that's my solution for B. Again, this was my solution for A. We can look at C now. So C is now stating 4 times 2x plus 3 equals 5 minus x minus 2 here. So I'm going to use distributive property. So I'm going to multiply 4 by 2x and 4 by plus 3 here. And I'm going to multiply this as imaginary negative 1 here, right? So negative 1 times x here and negative 1 times the negative 2 here. So if I do distributive property, what I'm going to get is 4 times 2x is 8x. 4 times 3 here is 12. This will equal 5 minus x, or minus 1 times x is minus x. Minus 1 times negative 2 would be positive 2, right? And what I'm going to do is I'm going to collect my like terms. As you can see, I have x's here and x's here, and the rest are constants, right? So 8x, I want to move minus x towards this side here. So minus x, I'm going to add the x to both sides. So 8x plus x would give me 9x here, plus 12 equals 5 plus 2. 9x plus 12, 5 plus 2 is 7. And finally, I have, let's see, 12, I'm going to minus 12 from both sides. So I have 9x equals 7 minus 12, which is 9x here would equal negative 5. And finally, I would divide both sides by 9 to get my answer, right? So I get x equals negative 5 over 9 here. And let me just check this answer really quickly. 13 was my correct answer. 17 over 12. 17 over 12 is my correct answer. Give me a second here. 3. Oh, yes, it is. Sorry, this here, 2 times 4 here is 8. Sorry. And this here would be 17. Sorry about that. And let's see. Yes, x would be negative 5 over 9, like so. And then finally, for D here, I'm solving for m here would equal, m equals 8 minus 0, 4n. Oh, 0.4n, sorry. M equals 8 minus 0.4n. I'm solving for n, right? So all I'm doing here is I'm just rearranging here, right? So I'm going to add 8 to both sides. Or sorry, I'm going to subtract 8 from both sides. I'm going to get m minus 8 to get rid of the 8 on the right side here. So m minus 8 equals negative 0.4 times n. And then finally, I'm just going to divide everything by negative 0.4n to get n on one side, right? So it would be m minus 8 divided by negative 0.4. And this here would be my answer for n here. So this is exactly the same thing. They actually simplified it even further, which is totally fine. But this is also the exact same solution. Yeah, they just simplified this even more. But and they put because they didn't want a negative on the bottom, but it doesn't really matter of how you kind of solve this here. But this solution here is correct. Sweet. So so a solution here is correct. All solutions here are correct, I believe. Let me just check what they're doing here for a sec. So they divided both sides by 0.4. That's good. And then they split it up between m and 8 here, which is great. And then they just did they multiplied 10 to both sides to get rid of the decimal here, and then they just simplified. Yep, that's good. Solution is correct. Good explanation here. This was number 10. Did I do this problem already? I did. So this is just simply the repeat of this question here. So I think I added the same problem twice. I did. I just want to check if the solution here is correct. And let's see. Half of 2 to the 6th power is 32 here. So this here is correct. The solution is also correct. Because again, we have half of my half here. I'm going to multiply it by 2 to the power of 6. Again, the half cancels out to 2, so it's simply just 2 to the power of 5, which here is 32. So solution here is correct. Good explanation. So that's kind of all the grade 8 and grade 9 math stuff for today, because it's just mostly mostly those questions here. We still have a bit of time, so what I'm going to do is I'm going to see if I can pick more questions for us to do here. So just give me a second while I do this. I think I'm going to pick some harder questions. So let's do some grade 10, grade 11 math. Sorry about that. I'm going to pick like 4 more questions for us to do. Okay, so I think I picked 2 questions here. I just need 2 more. All right, so I think I have my questions here. I think I picked 5 actually, so I don't know if I'll finish all of these, but it's okay. Let's work on these guys here. I have half of 112. I think I did this problem already. Give me a second here. Yeah, I did this solution already. Maybe I might not have clicked the correct solution here. So give me a second. Solution is correct. Good explanation. Again, this was the first question I did, right? I don't know if I clicked the Solution here is correct. So this here was my work for this problem, right? Half of 112 cups here is 56 cups. So the solution is correct. Because again, we're just simply dividing 112 by 2 here. Oh, I think I picked the stream again. So just give me a second, sorry. I picked the wrong stream here. Gonna have to just go over all of these guys again. Sorry about this. All right, here we go. So there's some higher level math here. It's mostly you would find this probably in algebra, end of algebra 1 and algebra 2 maybe for these problems here. I think I picked 4 questions. So let me just scroll down here. So it says, what number should be added to both sides of the equation to complete the square? So 1. So I have x squared plus 8x equals 4. I think I've done this problem as well before, but in order for me to complete the square again, all I'm going to do is I'm going to, again, place 4, basically put 4 here into this left side here, so it equals 0 here. So it would have 8x squared plus 8x minus 4 equals 0. In order for me to complete the square, what I'm going to do is I'm going to take this b term. So I take this b term here. Here's my b term. I'm going to divide it by 2, and I'm going to square it here. So that's going to make my perfect square trinomial. So 8 divided by 2 equals 4. 4 squared would equal 16. So that's the magic number I'm going to use here. So x squared plus 8x. I'm going to plus 16 here, minus 16 minus 4 here equals 0, right? So my plus 16 minus 16, I'm simply just adding a 0. But in this case, this creates my perfect square trinomial here, right? So this is what I care about here. So this, again, this here entire thing is my perfect square trinomial. So this here simply just equals x plus 4 squared, right? X plus 4 squared would be x squared plus 8x plus 16. And then minus 16 minus 4 would be obviously negative 20 here. So minus 16 minus 4 equals 20. This would equal 0. And finally, I would bring the 20 back to this side here. So x plus 4 squared equals positive 20. So as you can compare from basically this formula to this formula, I'm adding 16 to both sides in order for me to complete the square. So the solution is correct. Number 16 must be added on both sides to complete the square. They got the exact same solution as I did here. So the solution is correct. Good explanation. Number 1. Number 2 here is asking, what will the density of the radius of a sphere if is halved, compressing the air within? So it's asking density if radius of the sphere is halved. What would the sorry, what would it do? All right, so we have the density equation. So we know that D here equals mass over volume, right? Mass over volume. And we know that the volume of a sphere here is V equals 4 over 3 pi r cubed. And this you can find from a formula sheet or whatever you want. So what's saying is if the radius is halved here, how would that affect the density? So I'm going to substitute basically this volume equation into this density equation here. So I get a new equation. I would get D equals mass divided by 4 over 3 pi r cubed, or you could rewrite this as 3m equals 4 pi r cubed. And this here is our density equation. It's asking us what would the density of the radius, what would the density be if the radius of a square of a sphere is halved, right? So assuming that r here equals 1, our radius here is r equals 1, right? What if it was halved? I would get something like this. G would equal 3m over 4 pi. R would be half, and this is cubed, right? And we can solve for this. We can solve for, or we can rearrange this to see how it differs from our original equation here. So this here would equal 3m over 4 pi, and then 4 pi, and the half cubed would be 1/8, right? 1/8 here. And this would equal, again, 3m over 4 pi times 1/8 here, simply just 2. So this all equals simply just 2 pi, right? So this would happen to the density if it was halved here. And then if it was my original equation here, what would I get? I would get, if r here equals 1, 1 cubed is simply 1, right? So I would have 3m over 4 pi here. So this here just gets removed. So as you can see, my proportions here, if it was halved, if it was the normal radius, I would have 3m over 4 pi. If it was the halved radius, I would get 3m over 2 pi, right? So this is a difference of half here. So again, the density will be, if a sphere is halved, the density would also be halved here. So again, this solution, new density of a sphere is 3 times. Sorry, just give me a second here. I don't know why it says 3 times here. So V is, again, 4 pi over 3. So I don't know where the math went wrong here. Just give me a second. 0.5 cubed is 1/8 times times 4 is half. Sorry, I messed up here. This is not 2. This is half here. This is half pi here. So it's comparing. I'm comparing these two guys here. Yes, this is correct now. So 3m here and half pi, 3m over 4 pi and half pi here. So I'm comparing half pi and 4 pi here. And as you can see, this is a difference of, if I basically ignore the numerators, because the numerators cancel out 3m and 3m here, I can set this as half pi here equals 4 pi. The pi's will also cancel out here, right? So half equals 4 here. So this, or you can say what is the difference between this proportion here? I'm going to need, again, half times, I guess you can think of it as x or c or whatever you want. X here would have to equal 8 for us to satisfy this equation. So therefore, the density of a sphere would be 8 times the old density. So this solution here is correct. I messed up here and it said 4 times 8 is 2, whereas 4 times 8 is actually 1/2. So I forgot to include the half here. So this solution here is correct. Sorry about that. Good explanation. Let's look at number 3 here. It's asking, why is cos 0 equals 1? So you can answer this using the trigonometric circle that they've provided here, or you can just simply graph the function, right? If I had a function like this, so if this was, let's say, 0, pi over 2, pi, 3 pi over 2, and 2 pi, we know that cos starts at 1 here, goes to pi over 2, heads to, this is -1 here, and then goes back up, right? So sorry about the bad curve here. And then back up to pi here. Something like this. And it goes back out. Just trying to draw. You can never go through that line. There we go. This is my very poorly drawn cosine kind of graph here. And it says, why is cosine 0 equals 1? Well, the graph says so, right? And cosine of 0 here equals 1. This is a graph of y equals cos x, right? Or you can say, or you can prove it using the unit circle as provided on the left here. And as you can see, they have a unit circle with a radius of 1 here, and they drew a right triangle, right? So again, this is 0 here, or theta, you can say. Theta is this angle here. You have cos theta of 0 here is this point here, and this the y-axis would be our sine theta, right? So as you get closer and closer to 0, as you can see, this will equal 1 here, because my radius here is equals to 1. And then as I move up, again, it's going to go towards 0, and then it goes towards -1, and then towards 0 again, and then back to 1 here. So as I move my angle forward, as I move my angle towards 360 here, those are my answers here. So cos of 0 would be simply just this angle here, and as you can see, this angle here, because it's my cosine theta axis here, is going to equal 1 here. So the solution here is correct. Good explanation. Finally, I believe this will be my last question of the day. How do you find the exact value of sine 45 degrees? So sine 45 degrees is a special kind of a triangle, right? So sine 45 here. I have two special triangles here. This one specifically, I'm using this triangle here, which is a 90 degrees here. This will be a 45, and this here is a 45 degrees, right? So again, because I know for a fact that this is a right triangle, and both here are both my angles here are the same. That means I'm going to have the same lengths for these two guys here. So I have 1 here, and this would be root 2. So this here is a special triangle. You need to know these special triangles. The other one is a 60, 30, 90 triangle that you need to know as well. So the other triangle, I can write that down as well. This would be again, this would be another special triangle that you would need to know. And you can work with this in terms of in radians, or if it was in degrees as well. So I'm going to write this down in terms of radians. So don't worry if you don't worry about it. So I have here, this would have been a 60 degrees. This here is a 30 degrees, and this would be this here is 1, 2, and this is root 3 here. So again, these two special triangles I need to know. So I'm going to follow this triangle here, right? So this triangle here, because I'm looking at the sine 45, right? So sine 45, again, I can take any of these angles. I could take either this angle or this angle. I'm going to simply use just this bottom left angle here. Sine 45 degrees is simply just my opposite over my hypotenuse. The opposite here is 1. Again, it's 1. My hypotenuse here is root 2. So it's going to be 1 over root 2, or if you rationalize it, it's root 2 over 2. So this solution here is correct. As you can see, it would be 1 over root 2. So this solution is correct. It's good explanation as well for my and I like how they included the special triangle here. So solution is correct. Good explanation and inclusion of special triangle. So that's all going to be for today. Again, I've done, I think, about 15 problems for today. Thank you so much for tuning into my video. What we're going to do is, again, if you were kind of tuning in for the first time, thank you so much for watching again. Again, my name is Joey. I stream from Monday to Friday. Monday, Wednesdays, Fridays are my math sessions, and Tuesdays and Thursdays are my chemistry sessions. So if you wanted to learn math, definitely check out those times as well. If you want to learn chemistry, feel free to tune in as well. If you have any questions, again, you could always contact me through the chat while I'm live streaming, and I can see if I can help you answer those questions as well. With that being said, again, there's going to be upload of this kind of video on the YouTube website, on the YouTube OneClass channel. So you can click youtube.com/OneClass, and you can access these videos free of charge as well. So again, thank you so much for watching. Again, my name is Joey. Again, I will see you in the next video. Again, thank you so much for watching. Stay safe, stay healthy. Have a great day. Take care.